All right. Welcome, everyone. We are live. Oops, sorry. There you go. Um, Technical difficulties. Hi, everyone. Welcome to our September community call. We're thrilled to have you here as usual to discuss about OpenReplay and to also have some interesting conversations about technology. So today with us, we have, as usual, Mary, our CEO, and Luca, who's coming from the Dino team, and he's going to be sharing some interesting facts about hey about Fresh. So let's just add the presentation here and let's get started. So the agenda for today, as usual, is we're going to be sharing some product updates at the beginning. Then we're going to dive a bit into the licensing of the product, show you a bit more detail how we do that, and then we'll zoom in into what is or how to do data sanitization with OpenReplay. Finally, to close with Lucas uh, talk about Fresh. But before we move forward, as you would say, if you're new here, if this is your first time and you don't know what OpenReplay is, just know that it's an open source session replay suite by the by the developers for the developers. And if you want to know more, just visit openreplay.com or join our Slack community with the link at the end of this presentation. Anyway, so let's just go over. Let me just move everyone out and just leave Mary in so he can start here. And
All right, cool. Yeah, I think it's visible to everyone. Um, well, hello, good morning, good evening, everyone. Fernando, I think, well, at least here, at least on my screen, it's not showing up correctly. You probably have a window on top of it
I don't
for
actually.
pitch. Okay, can you? Yeah. Okay, fine.
That's
Let's stay here. All right.
yeah, yeah.
All right. So, yeah, hello, good morning, good evening, everyone, wherever you are. Hopefully, you had a great summer. We've been hard at work, and we should be shipping right after this call v1.8. So let's get the ball rolling. So what's up? I think the star of the show, or more accurately, the star of this release is going to be X-Ray. So X-Ray is a new way of showing an overview of all identified issues in a recording. You may have noticed, especially on those big and large recordings, the progress bar would get cluttered, and that's hard, especially if you're looking for a particular issue, whether that's a network failed request or a performance glitch or an error or even a click rage. Having all those events on the same progress bar makes it hard to navigate and get to the root cause. So we decided to separate that. We gave it a fancy name. It's called X-Ray. And there you're going to get the overview about those issues and you can quickly jump right into them. We also added the support of virtual DOM across the session replay. While you may not really notice the difference if you are on a short recording, on a large replay, especially if it's full of events, you're going to see it. You're going to see a big enhancement, a big jump in terms of performance, and especially when you're jumping from one end or one part of the recording to another. And then finally, when it comes to the session replay, we added support for keyboard shortcuts. So now you can navigate every recording using 3 or 4 keys. You can move forward, backward, you can jump right from your keyboard. So that makes things much easier. On the assist level, now it's possible for multiple agents to join the same call. So if there is any ongoing call, any new agent connecting to the same live session can jump on that call, which was not possible before. And we also added the ability to play back the past activity. What I mean by that, let's suppose you're trying to support or help or onboard one of your customers during a live sessions and you need to see what happened before. On previous versions, you would have to move into the sessions page, find that recording, what we call an offline recording, make some sense out of it, and then go back to the live session. Well, now that's you simply need to click on a button and get back to see the past activity and move back and forth between offline and online kind of mode pretty easily from the same window. On the tracker level, we added the support of Shadow DOM. This has been requested for at least 3 months by the community. We finally did it. So if your application is using Shadow DOM, that should be supported. And then we extended also the support of iframes. There were a few things missing for a perfect, I would say, replay of iframes. We were not properly capturing the click and scroll events, on hover events, and so on. So we just extended that support to the iframes. On the backend level, we've done a big job on improving each and every microservice, and by adding something we call message size in our protocol. So our protocol is basically the blood of OpenReplay. These are all the messages that get exchanged between the tracker, or starting from the tracker down to the database, right? So all of our microservices, all of the backend is following and using the same messaging protocol. And we added message size. So now we can compute the size of each and every message that we're sending. So all of the backend components can simply skip whatever message they deem unnecessary. And what's the output? Well, the output is better scalability on the backend and more session that could be captured. We also added the support of bulk inserts when it comes to the Postgres. Now, talking about the UI UX, I think you've noticed that, and this is like a big work that we started back from version 1.6, and that we're going to continue over the next one or two versions. We have redesigned, and we've been into this work of rethinking a lot of the workflows and a lot of the screens that we have. And in this version, we have completely redesigned the sessions list, the preferences section, alerts, and also slightly improved the dashboard creation workflow. And that work is going to also continue in version 1.9. So what's next? If you could move to the next one, please. I think it's taken time to, yeah. It's probably you could, yeah,
There you go.
that's great.
I don't know what's happening,
Yeah,
but yeah.
that's great. That's fine. That's fine. All right. So we're gonna. I was talking about the UI UX, and we're gonna continue that work, and most of it will be done by the next iteration or the next version, which is going to be 1.9. We're going to be improving the navigation flow in DevTools, right? So we got a lot of feedback saying that scrolling through all of the network events or the fetch requests or the GraphQL queries could be better, let's say. And so we're rethinking that flow, and that should be done by the next release. On the assist level, we're going to add the support of the multi-screen. So what we call multi-screen is basically the ability to see up to 4 live sessions at once. Now, why can that be useful? If you think about onboarding an organization, or if you think about supporting 2-3 users at the same time, that could be very handy. On the tracker level, we are slightly improving the sanitization. And by the way, in a few minutes, Fernando will be describing how you can sanitize data in general in OpenReplay. But for the sanitization itself, some of it requires instrumentation, right? So some of it requires using some HTML attributes to go and flag or tag that UI component that you want to sanitize, that you want to reduct. And what we got from the community as a nice improvement is to be able to use existing class names. So that's going to prevent the users from having to instrument each and every UI component. So this is something we're going to be introducing next. We're also adding context to all the errors that you can send us, such as tags and key value pairs, and support for the on-prem SDK. On the backend level, we will be able soon to blacklist, sessions or replays by a list of user agents and IPs. On the front end, we will be completing our move to React 18, but we also will be introducing notes. It's pretty interesting to see the feedback we got from some of the product managers or the designers that have been using our tool. And notes is a nice way to obviously take notes, share it with the team, and also use them to start a conversation on Slack. So we will be implementing that. And finally, on the integrations front, we will be adding support for Microsoft Teams. All right. It's getting slightly better. Yeah, on 1 or 2 words about our license. As you all know, we're having a mono repo for various reasons. And that repo relies on different licenses. I'm going to skip the enterprise edition, which requires an enterprise license, and I'm going to focus on the open source edition. Open source editions comes in two flavors. So there are components, they're under the MIT license. So that includes our tracker, all of the plugins, and recently with version 1.8, our OpenReplay protocol. The backend, frontend, and API are licensed under the ELv2, so the Elastic version 2. Just very quickly, and as a summary, Elastic is a non-copyleft license, which would basically allow you to use the product for your business, copy, modify it. There are very few limitations, but the only big constraint is that you cannot host OpenReplay and compete with us. So this is how we can ensure we can have a viable business. But if you need more details about it, I'd highly advise you to check our community call from April, and this is where we present the Elastic V2 license in more details. All right, before passing the mic to Fernando, kudos to all of the contributors from the last 2 months, especially Bart, Jorgen, Bass, JNCR, and Daniel. Hopefully, I'm not butchering any name. All these PRs are being reviewed and should be merged soon in the upcoming versions. Thank you.
All right. Yeah, I'm getting the hang of it. I don't know why it's doing what it's doing, but I know how to fix it. Anyway, thank you, Mary. Sorry about the technical difficulties, everyone, that we're having. I don't know why this is happening, but anyway, so let me just get started with this side of the presentation. All right. Hi, everyone. I'm Fernando at NetDevRel at OpenReplay. And today I'm going to be talking about data sanitization in OpenReplay, and most importantly, why would you want to do that? So why would you want to sanitize the data? Well, the main reason is because during your capture of the user experience, you might also be capturing personal information from the user. And while the user is trusting that information into your application, they're not necessarily trusting that information on your replay. And obviously, there are always privacy and security policies to comply with within companies. So we at OpenReplay, with the tracker, help you comply to them with our sanitization policies. So what kind of sanitizations can you achieve through OpenReplay? You can obscure text characters. You can see that the asterisks on the screenshot. Those are essentially characters that are being changed into asterisks. You can see how many characters are there, but you really can't read the text. You can obscure a whole block of render HTML, and you can see that at the bottom with the black boxes there. You can't really tell how many characters are there or what's in there. You can only see that there is something being rendered there. And finally, you can also remove a whole piece of the HTML from the DOM. You can essentially remove nodes from it. And you can see that at the top and at the bottom of the screen, on the list of input fields where there are blank spaces, there should be 2 input fields that were rendered out of the recording because of the tracker. And the main thing to remember here is that whatever you do and whatever type of sanitizations you go with, they will not affect the user experience. They will not affect the way your user interacts with the application, and the user won't even notice that is happening. So that is the main thing here to remember, that what your user sees when they're using your application and what you see when you're reviewing or replaying the session is not going to be the same if you're sanitizing data. So other considerations to remember: password fields will always be ignored. They will never be captured by the tracker, and you can really change that default behavior. You see that on the screen, the password field is empty. That's because we're not even sanitizing it. We're just ignoring it completely. Credit fields are pattern matched, means that if you're starting to input a big enough number on an input field, we'll treat it as a credit card number and we'll sanitize it for you automatically. And all of this is going to happen at the source. That means this is all going to happen during the session of your user, and they will not see it, but the raw information is never going to travel back to OpenReplay's backend. whatever gets recorded and sent but as part of the recording is going to be already sanitized at the source. And finally, if you want to affect these default behaviors, or some of them at least, you have global configuration options at the tracker level, or even you can go all granular and affect single HTML nodes using a set of custom HTML attributes that we're giving you. And that's what we're going to talk about now. So if you want to change or affect the way you sanitize a specific field, you have 4 different attributes at your disposal. The first two of them, let me just go here. The first two of them, the obscure and hidden attributes, they will only affect input fields. The first one will change the characters to be asterisks, and the second one will treat it as a password field. It will ignore all input. The second two, mask and HTML mask, they only affect HTML elements except input fields. So whatever it is outside and rendering text, you can mask it with the black boxes, or you can completely ignore it, remove it from the DOM. And we're going to see an example of that in a minute. So if you're instead wanting to affect the global tracker configuration, you can affect the way that text nodes render numbers or emails. And you can also affect the way we capture emails and dates on input fields. And finally, if you want to affect the behavior for all input fields that are not either password, emails, or dates, or big numbers, you can do so through the default capture mode. Right now, by default, if it's not one of these I mentioned already, it's going to be plain text. Essentially, we're going to capture whatever the user inputs, and you can obscure it or ignore it, essentially by default on all of them. So let me give you a quick demo of what I mean. Here I have a basic React application. It's just a form that will send information to the backend, and the backend will just return it, and I will render it. Right, so I have a bunch of personal information here which I can enter and show you. Oops, well, if I can actually input my email and my password and my credit card number. Yeah, this is the real one, and my address. Right, so whatever I enter is going to be shown back to me as a user. This might or may not be the ideal user experience, but at least it's my application experience, and this is what my users are intended to see, right? But you, as a developer trying to pinpoint a bug on the application, should not be looking at the user's credit card number or the user's password. So instead, what you're gonna see is the following. Let me show you. I have a bunch of replays here. So this has been pre-recorded, so you don't have to wait for the recording of my test to go into the application, into OpenReplay. But as you can see, credit card number, email, password fields are already being sanitized by default. The address field, since it's just a text field, is not going to be sanitized by default. But I already, on the render text, I have already added some sanitization. For instance, the email, the address, and the password field are being masked, as you see here on screen. Let me just pause this. And the email field, I did not affect it, but by default, as I already told you, the tracker is sanitizing it anyway. So it's picking up the email and it's showing you that there is an email there, but you can't really tell what it reads. The credit card number, I just left it blank, so it's showing the raw data. But let's focus on the address here. I'm already sanitizing the render address, but I'm not sanitizing the input field. So this renders my sanitization a bit kind of pointless because the value is still visible. So if I wanted to sanitize the field here so that whoever is watching the replay will not be able to read my address, I could not just add one of the two attributes meant for input fields, because this is not just an input field. This is actually a text field component from the material UI library. So I can't really treat it as a native input field. However, I can use the data OpenReplay HTML mask attribute. And what this will do, if you remember, is it will completely remove that node from the DOM when the rest of the DOM is being tracked. So if I go back to the list of replays and I show you how that looks, you'll notice that this is another replay I recorded, and you don't see anymore the address field. I was already using the HTML attribute here, so you saw that the user experience is not affected at all. However, during the tracking process, that information is being ignored completely. You see that the address is still here being masked. However, the input field is not showing. So that's it for the demo. So remember, data is sanitized at the source. That's the main thing. Raw data that you want to sanitize will never travel back to OpenReplay's backend. Some fields by default are going to be sanitized, and if that's enough for you and for your use case, that's great. If that is not enough and you want more control, you have your global and your granular options. Now, remember to back to what Mehdi said, on 1.9, the next version, we're also planning on adding class-based sanitization, essentially granular sanitization. Right now, if you are adding OpenReplay into a big application that's already functioning and you want to sanitize specific fields, you'll have to go one by one and add these attributes. In the next version, you're going to be able to capture them through class names. So if you were already kind of planning something around sanitization and using specific classes for those fields, you'll be able to affect them through that, and that's going to be much easier and faster to get going. So that's it for the sanitization portion of this talk. So we'll move on now to Luca with his talk about creating fast websites with Fresh. So Luca, it's all yours.
Cool. Thanks for having me. So I am Luca Casnato. I work as a software engineer at the Dino company. I'm working on the Dino CLI, Dino Deploy, and the Fresh framework. And I also work on web standards in TC39, which is the standards body that develops JavaScript, and also W3C and Whatwig, which develop web browser standards. I also am a chair of the Winter CG group, which is a community group, also standards related, which tries to build uniform standards for server-side edge runtimes. So that's enough about me. What am I here to present today? So I'm here to present an introduction to Fresh. Fresh is a new full-stack web framework, which we have been building at the Dino company. It's a modern framework that is built for Dino and on Dino. It uses a lot of the tooling that Dino provides, and it's really built for very high speed, very good reliability, and being super simple to develop with, both for the developer and also it should be really simple in how it works, so that there's no like big abstractions that could create performance concerns. Fresh really embraces server-side rendering and partial client hydration with islands. I'll get into more into that, what that is, in just a moment. But first of all, let me give you a quick recap on why we even want to do this in the first place. So Dino is a new edge runtime and client runtime for JavaScript and TypeScript, similar to Node, which was built by the same people that had originally built Node, Ryan Dahl, Bert Belder, and Ben Nordhaus. And it essentially tries to fix a lot of the issues in Node. So Node is pretty old. It's like 10 years old at this point. And because of that, a lot of features did not exist in JavaScript 9 years ago. And they do now. Things like promises, like readable streams, writable streams, things that are very in like modern web browsers today that we use for streaming. And a lot of other things like this. Node had to invent proprietary APIs. And in Dino, we essentially started from scratch and essentially started from scratch and took all of these modern JavaScript and web platform features and put them into a new runtime, which is meant to be really easy to use for web developers, because you can like reuse the same knowledge that you already have. And another selling point for Dino is that it is very well integrated. Like Dino is not just a runtime; it is also a formatter and a linter and a test runner and like a language server for your VS Code or your Vim or whatever else you use to code with. It's like it's a fully integrated system that you can essentially use to build your projects with. And Fresh is really an extension of this. So Dino was built for server side and like being the best at server side JavaScript runtimes, and Fresh tries to extend this to be the best in client side JavaScript as well. So how do we do this? Fresh has a bunch of standard features which set it apart from other frameworks, other web frameworks. For example, Fresh really is all about just-in-time rendering HTML. So instead of server-side rendering HTML, or sorry, instead of like rendering HTML in a build step, for example, Fresh will render as the user requests a page, which allows the render to include personalized information for that user, like login state, their name, their settings, stuff like that. In addition, we are very, very conservative about the amount of JavaScript that we ship to the client. We try to ship no JavaScript to the client at all. And actually, by default, Fresh ships no JavaScript to the client. I'll get more into why that's important in just a moment here. And part of that is that whenever we do ship JavaScript to the client, it's very localized to like a specific piece of the page that requires interactivity. Like we don't just throw JavaScript at the entire page, and instead we like are very specific about where we put some JavaScript to like increase interactivity or the user experience. Fresh also has no build step. There's no configuration necessary. It's TypeScript out of the box, and it integrates really well with the rest of Dino. So you can use Dino's regular linter formatter, test runner, and everything else like you usually would. Yeah, so the problem about JavaScript on the client is that current frameworks ship way too much JavaScript to the client. There's multiple pieces to this. So first of all, JavaScript execution on the client is really expensive. Like if you send 1 kilobyte of HTML, the browser has to evaluate that HTML once, it builds a DOM tree from that, and it can then essentially forget about it. Whereas with JavaScript, if you send 1 kilobyte of JavaScript, that is a continual cost to your client. It has to execute this JavaScript, it has to keep this JavaScript compiled, it has to maybe execute this JavaScript later when you click on something, or if you're doing some fancy animation with JavaScript, it'll like execute some JavaScript every frame. It's gonna be very expensive. And if you do this for things that really don't need to have JavaScript, for example, you have some static content like a blog, and you can server-side render that blog content, but you also ship some JavaScript to the client to also do that rendering on the client, then you're really just wasting your client CPU cycles. And if you're on a mobile device, so what you want to do is you want to minimize the amount of JavaScript that you ship to the client. Also on slow networks, that just makes your page load faster. So what is the solution to this? The solution is instead of shipping a bunch of JavaScript for the entire page, like frameworks like Next.js or Remix do, where essentially they will render some, like some frameworks at least, they will render your page on the server, ship the HTML to the client, which is good, that's server-side rendering. But in addition, they will also take all the JavaScript that they use to render that server-side HTML. They will also ship all of that to the client to then do another render on the client. So they do a full client render and a full server render. And that's really wasteful. So what instead is a good solution to this is to do a full page render on the server and then only send the JavaScript to the client for pieces that are actually interactive. And then if you look at this little diagram on the right here, you can imagine this is like a page. This is a blog page, for example. You might have a header, which has like a login button and a sign up button. Those need to be interactive. You have a sidebar, which has a search field in it that needs to be interactive. You have an image carousel, where like you might want to be able to navigate through the images by pressing left and right on your keyboard. That needs to be interactive. But you have the actual content of your blog, which contains like text and images, which really doesn't need to be interactive. Like it's static content. So you don't need to send any JavaScript for that. But for the things that are interactive, like this header or the sidebar or the image carousel, those are interactive. So you do need to send JavaScript for those. So and by like sort of splitting this up, you can have real gains in the amount of JavaScript that you send by, yeah, essentially not sending a bunch of a bunch of stuff for pieces of the page that don't need it. Part of the problem is, though, that even though many people agree that server-side rendering plus like partial hydration islands are the best way to make websites right now, it can be quite challenging to do so. Like if you want to do this manually, you have to essentially have a server-side rendering framework and then have a separate framework to do the client-side rendering ergonomically, and that's very painful. Many people don't want to write their websites like this. So if we want people to write fast-performing websites, we need to make it really easy for them. And part of making it really easy is making it really ergonomic. So Fresh tries to take the server-side rendering and islands concept and make it really ergonomic and really easy to use for people. So how do we make it ergonomic? For example, we take away all the configuration that people need to do. We give them a single command that they run, and it'll scaffold out a project, which on that project, they're right on the fast path. Like they don't need to think about crazy things. They don't need to learn a lot of new skills. They can use the skills they already have from other frameworks, which is like really important. You really want to make sure that you tie into the user's existing skills that they have, so they don't have to like relearn everything when they start using your framework. And if you combine all these things, you get something pretty ergonomic. And this is really what we try to do with Fresh. We make it really easy to get started with a new project. You just run this command, and it'll generate a project boilerplate. And then inside of there's only like 3 folders. There's only really 3 new concepts that you need to learn when you're using Fresh. And if you actually come from Next.js or Remix, there's probably only 1 new concept that you have to learn. So let's go through some of these important folders it creates. So there's a routes folder that is created. This contains source code for your server-side rendered routes. The structure for this is very similar to Next.js. So if you've used Next.js before, you'll know what this looks like. You can have like a routes/index.tsx file, which is rendered if you go to the root of your project. You can have a routes/about.tsx file, which gets rendered when you go to the about page. You can have dynamic routes using pattern matchers in your route names. There's more documentation on this in the Fresh documentation. But this is, essentially file system routing, very much like Next.js. A lot of people are familiar with this. Then another important folder is the components folder, which you're probably also familiar with from frameworks like Next.js or Remix. These are just general purpose shared components that you use. Like, for example, you have a button component, which has some UI styling and maybe has some accessibility features that all of the buttons across your application should share, and you have this shared component/button file, which defines that component. So this is very typical. A lot of people are familiar with this. And then the thing that's really special about Fresh is this islands folder. The islands folder is very similar to components in that you can create like JSX, you can define JSX components in there. But the difference is that these components are special in that if you render them on the server, they will automatically figure out how to rehydrate themselves when the HTML that was rendered on the server gets sent to the client. So that means you can, if you're writing a website and you want to have some sort of interactive anything, you can just make sure that your interactive component is inside of the islands folder, and it'll then get rehydrated on the client. And anything which doesn't need to be interactive, you can put in one of the other folders. And that way, it's really easy to split between like not shipping too much JavaScript to the client, because you can be very specific about these things are interactive, they go in the islands folder. This is not interactive, it goes into the components folder. And then it's really easy to start the project with just a task start. So let's look at what some of these files in these folders might look like. So inside of the route folder, for example, you might have an about.tsx page, as I alluded to earlier. This will get rendered when you navigate to your page/about. And you can see this really just exports a JSX component as the default export, where in this case it returns a main tag with a heading and a paragraph in it. And this is like super easy, right? This is very familiar to a lot of people. It's very much what it looks like to render a page in Next.js or Remix. Then you want to have an island. So this very much looks like a regular Preact or React component, like a shared component. It takes in some props, in this case a start number, and it renders out some HTML structure, and it has some state. And this state is what makes this component interactive, right? If you want to have some state that increments or decrements in the browser, that needs to be interactive. So when the user clicks on the plus or the minus button, it'll decrement or increment the state and change the output of this counter component. And then to just use this island in a route, it's super easy. You import it into your route file, and then you just use it like any other JSX component. And under the hood, Fresh will figure out that this is an island, and it'll rehydrate it on the client, and it'll ship just the JavaScript that's needed to render this counter to the client and nothing else. Yeah, so that's the really short explanation of Fresh. You can try it out yourself at fresh.dino.dev. You can join our Discord at discord.gg/dino, and if you want to deploy your Fresh project to the edge, you can do that by going to dino.com/deploy. And there's actually a bunch of, like, one question I always get is like Fresh used in production anywhere? And it definitely is. Like, Fresh is what powers dino.com, dino.land, and many other Dino web properties, and also a bunch of other sites. We're actively building out a showcase section on the Fresh homepage, where you can see a bunch of the projects that use Fresh. Yeah, so that's my quick introduction on Fresh.
Awesome. Thank you, Luca. It was really, really detailed and interesting. I actually, when I heard about it, I just fell in love instantly with Fresh. And I've tried it for a few side projects, and it's really, really interesting and easy to use. We do have, if you're interested in Deno or Fresh itself, we do have 2 more episodes about those topics on our podcast, on the 20 Minute JS podcast. So we invite you also to listen to that. Luca is actually in one of those, so he's also obviously talking about Fresh. So that's it. Thank you, everyone. Remember that we do this every month or so. So if you want to stay updated about when we're doing this and everything about OpenReplay, follow us on Twitter or join our Slack community with the link on the screen. And also remember that we have a weekly podcast where we share interviews with people from the community, with the JavaScript community, like Luca and other people. So check it out. It's really, really interesting. And before we go, actually, I'm talking about in the screen as if you were seeing something. Sorry about that. I was seeing it. You weren't, but now you are. Sorry. And now that's it. Finally, just a reminder that we're always hiring for these roles. If you are interested in them, or if you know someone who might be, reach out to us on Slack, and we'll take it from there. Thank you, everyone. Thank you, Luca, for your time and the explanation, and everyone else. Thank you. We'll see you here next month.
Thank you so much for having me.
Yeah, absolutely. Bye, everyone.